What it do, baby? It's your boy, the NetworkBruh, in the building. Back with another live lab, episode number 73. We're almost done with the book. Today we're doing static routes and ACLs. Access control lists. This is challenge lab number 1 in the book. Page number 469 if you got it. Hopefully you do. If you don't, this is the lab guide we use, 101 Labs, Cisco CCNA version 4. You can get a copy of this from 101labs.net. It's authored by Paul Browning and Farai Tafak. There is a link in the description box below if you want to get a copy of it on Amazon or whatever. What we got going on today? Yeah, basically 2 routers. That's all we need. 2 routers. Go ahead and fire up 2 routers, whether you use a GNS3 or packet tracer. I don't know if you can use packet tracer because I don't think you can change the source interface. So if you got GNS3, even G, CML, or real hardware, I'm going to be using real hardware. Just go ahead and drag and drop 2 routers, router A, router B, and then cable them up with a serial cable just like that right there. I guess it don't really have to be a serial, but if you want it to be exactly like the lab, you got to make it serial. Y'all know I leave my routers as numbers, right? Router 1 and router 2, router 3, etc., etc., etc. But for this lab, they made it router A and router B. So I'm going to go ahead and do that while you guys get your emulators powered up. I'm going to change him to router, if I can spell, router A. And the other guy going to be router B. All right, he's going to be router B. And basically, well, I'll go over what the objectives are. We're going to create some static routes, obviously, and some access control lists. Spoiler alert. Router B, right? I'm going to give it some time for some people to tune in. Y'all know some people that be walking in. Let's put some mamas cooking on the routes and ACLs. Let's do this. Professor Black Ops. Shout out to Professor Black Ops. Again, if you guys are into cybersecurity, I'll go ahead and check him out. But yeah, we're going to work on some static routes and access control lists. It shouldn't be that difficult. Obviously, there's only 2 routers here. I noticed, like, you see some IP addresses floating right here beside the routers and stuff, right? But basically, we're going to use those as pretty much destinations and sources and say who can go where, right? And who can't go where. And we're going to do this with access control lists, right? That's what access control lists do. It allows you to filter traffic to and from your, source and destination, depending on whether you're using a standard ACL or an extended ACL, right? Y'all know the difference between the two, right? Standard, you can only define the source and whether to allow or deny that traffic. Extended is a bit more granular. You could do a lot more with it, right? So you could define the source, where the traffic is coming from, the destination, along with the protocol, and say allow EIGRP traffic to come from this network to that network, right? So let's say we had traffic coming from this network, traffic coming from this network to that network, right? We can only allow, let's say, I don't know, OSPF traffic to come to that, right? But right, so OSPF, right? But let's say we had we want to block EIGRP traffic for whatever reason, I don't know. And we can do that with access control lists, right? With extended, because we can block traffic we can block specific type of traffic with both, but extended, you can block, again, the source, destination, along with the protocol. Standard is just the source and whether to allow or deny it. Now, the way I remember that is the S for standard, you can only define the source, right? So where it's coming from. I guess we can get started, right? We got Dave W in the building. Appreciate you for tuning in. Evening, Professor. He said Professor. I guess you Professor Black Ops you're referring to. Let me go ahead and turn my light on. Let me know if y'all ready. Are you guys have your simulators or emulators powered up? Again, I don't think you can do this with packet tracer because packet tracer, I don't think you could change the source interface, right? So like, let's say we have some traffic and we wanted to specify a specific type of traffic coming from here to there, right? But we're going to say coming from this, though. You can't change that. You can only go out of that specific interface. You can't say coming from this or that, right? If that makes any sense. You can't change the source interface, which I'll show you how to do that if you don't know how. So let's go ahead and get started. Y'all ready? Page 469, you got the book. This is the challenge lab, right? So we're almost done with it. We're on the tail end of this book right here. The book has, I know it's called 101 labs, but they actually had, 105 labs, which we finished 108 yesterday. And then they got challenge labs. They got 15 challenge labs. And once we're done with that, we're going to move on to the CCNP version of this. So a lot more difficult stuff than this. If y'all think this is going to be hard, this ain't even going to be that hard, man. All right, so task 1. Well, the purpose says, these are classic exam subjects you should be very familiar with. I hope so, right? Being on the CCNA, right? Rather than watch a video solution, if you have access to the video course, which, by the way, Paul Browning does have a video course, right, on CCNA stuff. Just go to his website, 101labs.net. I promote his shit like it's mine, right? I have provided show runs and test commands where appropriate, whatever. So, task 1, configure the topology above. Again, drag and drop 2 routers. Router A, router B, cable it up. I got physical routers. They're already cabled up. I'm ready to go, so I hope you guys are ready to go. Don't just watch. Remember, experts agree that we retain only 10% of what we read, but 90% of what we do. So do this with me. Task 1. You should be able to ping across, it says configure the topology above. So basically, this is what they want us to do, first of all, which we should know how to do this, right? They want us to configure this interface right here with that IP address, .1, right? What's that .1? It's 10.0.0. There's an X there, so it's a variable, right? So .1, give him 10.0, give him that IP address, 10.0.0.0.1. Same thing with this guy. He's going to be 10.0.0.2, right? And then they want us to do these loopbacks. Loopback 0 on that interface, that router. Loopback 1 on this router. Loopback 0 on that router. And loopback 1 on that router, right? Y'all know how to do that. If not, then just follow along, right? So on router A, we got these 3 interfaces right there, right? So let's go ahead and do that. Easy stuff, right? Easy stuff right here, right? Go to global config mode, interface. We're going to go to that interface. Remember, your interfaces might be different. Mine is serial 000. His was serial 00. His IP address, right? We're just doing basic homework here first. 172. No, I'm sorry. What am I doing? 10.0.0.1 subnet mask of /24. So 255.255 fat finger squad. 255.255.0, right? And then by default, show IP interface brief. Router interfaces are down by default, right? So you need to turn it up. On the switch, they're already up. But on the router, you got to actually turn it up with what? No shut, right? We do a no IP interface brief again, and you'll see it is down. Why? Because this side hasn't been brought up yet. That side hasn't been brought up yet. So that's why he is down. So we need to bring that other side up before we do that. But before we do that, we're going to do these interfaces right here. Loopback 0 and loopback 1, right? Y'all with me so far? This is easy stuff right here, right? Easy stuff, right? Interface, loopback 0. Anybody got any questions so far? Did I lose anybody? IP, I know somebody in there was like, man, you type you in fast, man. Slow down, man. 1.1 /28 subnet. So 255.255.255. What's that? 240? Yeah, 240. No, we don't need to no shut that, right? Because loopbacks, they come up automatically, right? So now we got to do loopback 1. So interface loop 1. His IP address is 192.168.2.1. Subnet mask of /27, which is 255.224. Right, 224. Let's show our work so far with show protocols. My new favorite command, show command here. 10.0.0.1/24. That's correct, right? That's this right here. Oops, right. That's that right there. Right, and then we got 192.168.1.1/28, which is that right there, loopback 0. And loopback 1 is 192.168.2.1/27. So that's correct too. So now let's go to router B and do the same thing, right? So we're going to do these interfaces right here. That interface, this interface, and that interface. Anybody got questions so far? I know this is the easy stuff right here. What's the lifetime of network hardware before upgrading? That depends on the platform. Good question though, Dave. It depends on the platform. Typically, I want to say, so there's different dates. You have end of life for hardware support. So like anything that's hardware that fails on it, after this date, they don't support it anymore. They also have end of life sale dates or end of sale dates. They call it EOS rather than EOL, right? So that's the last day they sell this device. They probably still support it, but they're not gonna sell it no more, right? So Love show protocols. No course or book taught me that. I found it in Cisco documentation. Man, Pete, shout out to you for that because I never knew about that command either. Never seen it in a book as long as I've been studying this shit. And you pointed it out to me. So shout out to Pete for this command right here. Show protocols. I love that command right there. But yeah, so there's different dates. There's end of sale dates. There's end of life dates. There's end of software support. There's a whole bunch of them. I'll pull them up maybe at the end of this stream or maybe in the middle of this stream when I got shit else to talk about, Dave. But good question, though, Dave. They vary amongst the different platforms, right? And vendors as well. So we got to go to router B, right? And go to that interface right there, the serial interface, interface serial 000. His IP address is 10.0.0.2/24. So 255.255.255.0, right? We got to bring him up, right? Once we bring him up, theoretically that should bring that side up because remember it was down, right? So now it is up. Let's go back on the other side and see, right? We got a message right there, up. So now let's check it out again, right? Show protocols, and now serial 000 is up. See that? So the other side has to be up as well for it to be up, if that makes any sense, right? Now let's do loopback 0 and loopback 1 on router B, right? Interface loop. Anybody got questions? I hope I didn't lose anybody. Y'all know I'm bringing along everybody with me, man. There's no such thing as a dumb question. If I can't get to it, there's a lot of smart people in the chat room over there. Y'all know I'll be talking so much shit that I don't be paying attention over there. So somebody else will be answering it if I don't get to it. /20 subnet is 248.0, right? And correct me if I'm wrong, but we'll check it anyway. 248.0. Yeah. No, I'm sorry. 240.0. Yeah, 240.0. We'll check it again, though. And then interface loopback 1. His IP address is 172.20.1.1. That's crazy, Pete, man. All those books never showed you that, and it never showed me that either. This is why it's important to look at these white papers, these other documentation that is not in like the official cert guide and these books like this right here. They're not gonna teach you that shit. You gotta look for it yourself, man. It's crazy, man. That's why Google, like, your Googling skills, your skills to search for information on the internet is just underrated, man. You're not gonna know everything. You're gonna have to look for it. So he's /22. So 255 dot what's that? It's not 240, 248, 252.0, right? And we'll check it. Now let's do show protocols again, my new favorite command. And we got 10.0.0.2, right? That's this guy right here. And we got 172.16.1.1/20. That's correct. And the other one is 172.20.1.1/22. All right, so I got my subnets right. Good to go. Good to go. Okay, so we did, that was task 1, right? We only got 4 tasks here. And then we should be, maybe if we got time, we'll do the second challenge lab. Who knows? Task 2. Actually, back to task 1. You should be able to ping across the serial interface only because there are no routes from the loopback network. So theoretically, we should be able to ping from here to there. Right? We should be able to ping from there to there. Right? Y'all know how to spell ping, but I'm going to write it out anyway. We should not be able to ping from here to here. Right? Bloop, bloop. And we should not be able to ping from here to anywhere else, like here or there, whatever. We should not be able to ping from those loopbacks and vice versa. Why is that? Because we don't have any routes to them. That's not going to be our pop quiz. That's an easy one. We don't have any routes to those loopbacks. But this right here, we are directly connected to it. There's a physical cable going from there to there. I have a cable right here to there. And if y'all, in case y'all haven't seen a serial, I actually bought a serial cable because I never knew how the shit looked like. They made me study it, reading all these damn CCNA books and all this stuff, but I never seen how a serial cable. I went on eBay and bought one so I could see what it looked like. But I have a serial cable going from there to there. Y'all let me know if y'all want to see how it looked like. But anyways, we should be able to theoretically ping from there to there. So we'll go router 8 and we'll ping 10.0.0.2. Pray to the network gods, and we got a reply. So we're good to go there. So he was right. Task 2, configure static routes on router A with an exit interface of its own serial interface so it can reach the networks on the loopbacks for router B. So now we should try to create some loopbacks or some routes that'll go from there to there and there to there and vice versa, right? So we tested the ping part, right? We tested this already. Now they want us to create some static routes to go from here to there and vice versa, right? So let's go ahead and do that. Let's see. He said on router 8, right? So we gotta go to global config. Anybody got a question so far? Did I lose anybody? Here's your 2 cents, man. Hey, man, what's going on? Hey, here's your 2 cents. You got a question? Let me know. So we got to create a static route. We know it starts with IP routes, right? He said from where to where? He said from the exit interface of its serial interface. So we know when we create this route, we need to get out of this interface right there. So that's going to be the exiting interface. We want to be able to reach the loopbacks on for router B. So from, got with me so far? We need to go from here to there and here to there. He wants us to create a static route for both of those. So that tells me right there, we need to create 2 static routes, right? Because these are 2 different networks. 172.16.1, that's 172.20.1. So unless we create some route that's going to encompass the whole subnet, it's probably best to just do specific subnets. So let's just do, to get to the 172.16.1.0 network, subnet mask of /20, which is 255.255.240.0. Take the exiting interface of 0.0.0.0, right? So this is the destination, and that is the source, 0.0.0.0, right? And y'all remember the syntax for static routes, right? It's IP route, and then source subnet mask, and then exiting interface or router's next hop, which would have been this. But they didn't say next hop, they said use the exiting interface. This is why I use that instead of this IP address. That make any sense? All right, so enter, inconsistent, oh, that's wrong. So let's see, what did I do wrong here? I'm glad we got this. 172.16.1.0, to get to that network, take 0.0.0.0. Interesting. Inconsistent. Let's see. 172.16.1.0. What did I do wrong here? Interesting. /240. Right? Wasn't it /240? To get to that network, take 0.0.0.0. Huh. What am I doing wrong here, y'all? Let's see. Let's see. That was it right there. 172.16.1.1. 172.16.1.0 network. Let's put a 1 there and say not network. What we should do is put the exact IP address though. Inconsistent. Let's see. Do I need the a wildcard mask? No, I don't. Destination prefix mask is /20. Interesting. 255.255. The networks aren't .1. Yeah, he did, but he said, this is what he said though. I see what you're saying. If you look at task 2, if you got the book, Pete, I know you said quad 0. I know you said 0.0.0.0. Yes, I see that. However, the second sentence says on router B, configure a default route. So a default route would be 0.0.0.0. So, yeah, that would be the default route. He said a specific static route to the loopbacks to reach those networks. So that's why I thought that would have been correct. But, yeah, to get to the 172.16.1.0 network, that's what I thought would have been. But I guess not. The networks aren't. Let's see. He said, I love static IPs so I can control traffic from the device level. Yes, I'm joking about the quad 0. Oh, okay, I see what you're saying. But still, that you will use the quad 0 on the second part of task 2, which is the default route. So 0.0.0.0 is a default route we could use. But for this, we wanted a specific static route to this network and a specific static route to that network. So he's saying probably because, let me see, 1.0. Huh, interesting. Although there is a solution guide, I'm just trying to refrain from using the solution from here. Why can't we use that, y'all? 1.1, 255.240.0. and then serial 000. But he says inconsistent address and mask. 172. Let me see. Did I put that address on there? Yes, I did. 172.16.1.1. Let's see what addresses are there. 255, 240.0. Yes. 240.0. But he don't like that. Interesting. And this should be a simple issue. What is going on here? I'm on router A doing that. Okay. Let's do this. Let's move on to the second part of that task, and then I'll go back to that one. This one, we'll do that default route that Pete was mentioning. So on router B, configure a default route so that all traffic for any networks are sent out of the serial interface. So that is what you were saying earlier. This right here, 0.0.0.0, 0.0.0.0. So any traffic needs to go out of the serial interface, 0.0.0.0.0, just like that. Boom. Show IP route, and okay, so that is the static route we just created right there. But we still don't have we still don't have routes to the 172.16 and 172.20.0 network. How do we configure that to the loopbacks on router B? Configure static routes on router A with an exit interface of its own serial interface so it can reach the loopbacks on router B. Why can't we do that? Let's do that again. Configure terminal, right? So we said IP routes to get to the network of 172. Let's try the second one. 20.1.0 network. Subnet mask of /22. So 255.255. Not 240, but 248, 252.0. Take the exiting interface of serial 000. Can you do that? Nope, you can't do that either. Interesting. Oh, if we add a .1, nope, we don't like that either. Let's just make it the exact network then. 255.255.255. Guess you could do that. The exact address, right? Can I do the same thing with the 16.1.1 network? 16. But he said reach the networks. So this need to be 16.1.0 like that. And the other one need to be 20.0. Either way it'll work, but and then get rid of the 1.1. Control A. No. Right? Take a look at our static routes again. Show IP route. Anybody did anything differently or how they did it? 1.1 are not networks. 16.0.0 would be the network. Yes, it would be, but that is the class full subnet, I believe. What you're saying, they put like variable subnet. So this would have been. This is actually supposed to be /16. This is supposed to be /16, but they created these variable length subnet masks, 20 and .22, which is not consistent with 172 network, right? Because these are class B. He said to do a host route /32. Yeah, and that's what I ended up doing, Aaron. Yeah, exactly, Aaron. That's what I ended up doing. But yeah, that's exactly what I ended up doing. Let's see. Let's take a look at our route table right now. Show IP. Show IP routes. Where we at? Did you guys get your routes so far? Because I'm clearly having some difficulties with these static routes, and I'm trying to move on to the CCNP topics and barely do a damn static route. What the fuck is wrong with me? And what's wrong with this? Let's see. I can get to the 172.16.1.0 network. Perfect. And the other one is 20.1.0 network. Good. So then he says here, ping all networks to check connectivity. So basically, this should be able to ping that and vice versa, right? And this should be able to ping that. No, not vice versa, because they said on router A. Oh, but the default route, what was that default route? This should have been on router B. So let me get rid of that. See? Let's do a showroom real quick. So you got to read instructions here. Let's see. Creed9 says, what's going on, bro? Sorry I didn't speak well in the room due to multitasking, but can you boot the configurations you need to set up in routers and switches from a USB? Boot the configurations you need to set up in routers and switches from a USB. Yes, you can. So you can put all the configurations you want on a USB, pop it into the USB port of a router or switch or whatever, if it's supported, if they have it, and then load the configurations from that. You just do copy USB and then the name of the file, the startup config, and then copy it to your running configuration or your startup configuration. So yes, you can do that from a USB. It's a lot easier than the other way. This static route right here, I need to get rid of. That needs to go on this guy right here because he needed a default route. So let me get rid of that. Right? Is anybody ahead of me so far? Because I know I'm probably holding y'all back. 30 minutes into the damn stream, we still on task 2. So know this, right? Go to router B and configure that static route. IP, nope, my bad. Boop. Right, so now he got a default route, show IP routes. So all of his unknown traffic is gonna go out of that interface right there. And now let's go ahead and get on our knees, pray to the network gods, and hope this works, going this way, and traffic going that way, along with this right here, going this way and that way. And theoretically, we should be able to ping from each one. So let's start with router A and ping, let's see what he said. Yeah, ping all networks, check connectivity. So ping 172.16.1.1. Pray to the network gods. We got a no. We need some troubleshooting here. Already into the stream. Shit. All right. Let's see here. Let's see what we got here. Show IP route. Oh, let's see here. Let's see what we got here. 16.0.0 network, which was this. Maybe I should just do that exact host route and not do the network. Maybe that's what I should do. Let's see what he said. Thanks, Creed9. Yes, so yes, that's what I was saying. You can use a whatchamacallit, a USB port. So that didn't work. 172.16.1.1. Can you do 172.20.1.1? That 1.1. This is, I see why he called it a challenge lab. So here I am thinking, static routes, we should be able to get through this quickly. All right, let's do this. We need to reroute this. Let's do this. Show run, right, and do routes. Include route. Let's take a look at this. What the fuck is that? Source route. I don't remember writing that. So this I need to put. Let's do what Aaron was saying. An exact static like host route. So I'm gonna do 1.1 and try that and do 1.1 for this one, which is what you just said, didn't you? IP route 16.0.0 serial triple to get you into the subnet. Okay, I see what you're saying. Okay, the routing needs to go both ways with static routes. Yeah, I see what you're saying, Aaron. I see what you're saying too. But we created a default route though on this guy, didn't we? Yeah, so he should be able to get to the 192 networks. Any unknown traffic is going to go out his default routes. So let's do this. Let's go to global config mode, interface. I'm sorry. Let's get rid of that. Let's get rid of this first one. We'll get rid of both of them. Neither of these are good. Notice. And get rid of that one. No, that. So what if I do an IP route just to the .1, exactly that address? I know you said 16.0.0. We'll get you into that subnet, the 16. Okay, but the same thing with the 20.0 network. Is that what you're saying? 20.0.0. Let me try this real quick. 20. 1.1. Do ping 172.20.1.1. Do pint. Yeah, so I was able to do it that way. Yeah, change it to 1.1. Set it in the network. Let's do the same thing with the other one, which is basically what Aaron was saying. I'm creating host routes. So I'm creating routes to exactly that address. Whereas Pete said do it by the whole network. So I guess we can go either way, but I'll check to see what he did. I'm gonna go with the host route. Actually, you know what? I did one host route, and I'm gonna do another one for the network. So I'm gonna do one for Aaron and one for Pete over there. So let's see. IP routes 172.16. He says 0.0, and then 255, 240. Right? Yeah, 240.0. Now I should be able to ping 172.16.1.1. We got a reply. Good to go. All right, so I got a host route for this one, and then I created a network route for this one right here. So network and a host route. And it was able to ping both ways, right? So if we go to route 3, we should be able to theoretically ping from here to there, right? Y'all let me know what you guys did. I see what Pete did, and I believe Aaron did it the same way. Honestly, it's not an amazing idea to use the egress interface for the next hop. Even if you don't see many negative implications, since it is a serial link, it's still not great for consistency, since it's a terrible idea 99% of the time for Ethernet. Positive said, bro. Shout out for appreciate you for tuning in from Israel, man. But I see what you're saying, Calvin. We should be using the exact subnet as our destination rather than just using the exiting interface. It's just, I don't know, for some reason it's just easier to do the exiting interface. But I'm gonna take note of that though. So he should be able to ping 192.168.1.1. Good to go. And then he should be able to ping 2.1. Good to go. All right, so we good to go. Jesus, we're having some difficulties there with just static routes. We haven't even got to the ACLs yet. Now on task 3 out of 4. Task 3. Adding an extended ACL on router B. So we need to go to router B, which we are on router B. An extended ACL. So we're going to create an access control list over here. That's going to be permitting or denying traffic, right? On router B to permit Telnet traffic to host 172.16.1.1. So we're going to allow Telnet traffic to go to that host right there. So I guess that is okay if I would have made it a host route because they said just host. So this, we're going to allow Telnet. We're going to allow Telnet, right? Did anybody complete this lab yet? I know some of y'all ahead of me. It's all good though. Allow to permit Telnet traffic to host 172.16.1.1 from any host or network. I guess we can just start with that, right? So we're going to go global config mode, IP access list. Being that he said he gave us a source destination along with the protocol, that tells us it's going to be an extended ACL, right? And then, okay, so it's from any host. So that tells us right there, any. No, you got to do the protocol first. So Telnet, you can't do Telnet, so you got to do TCP. No, you got to go into it. You got to name it. What am I thinking here? IP access list extended. So let's do allow. I'm going to name it allow Telnet. Now we're in extended ACL mode. Now I'm going to say permit. What am I permitting? Permitting any, the IP, the protocol. So in this case, TCP traffic. The source is any. Right? Do we got to do the subnet mask? No, we don't. No, we don't. We do the destination now. So now the destination is 172.16.1.1, right? That's the destination right there, right? This is the destination. And then I think the subnet mask. Yeah, the wildcard bits. So in this case, /20. But we're going to give it the exact IP address. So in this case, all zeros. That's going to match this exact IP address when we do all zeros like that, right? And then we're going to say, now we define the protocol. equals telnet, right? Can you do that? Yes. Okay, good. That's that first rule. He said, Mr. Browning loves cereal. Listen, man, I don't know why, but yeah, he got us using these serial cables like it's the wave of the future, but whatever. Well, cereal, but generally speaking, you want configs to be consistent, which means you don't want some static routes recursively routed and others to be treated as directly connected. Gotcha. Yeah, and I forgot what recursive means. I think it means they gotta look up look up on the IP table twice or something like that. Can't remember what recursive static routes are and stuff. Need to remember that though. All right, so we're allowing telnet there, right? With that rule. The second part of this task says, excuse me. Y'all run with that like button, man. All other telnet traffic should be denied, but all other IP traffic permitted. That sounds like a conundrum there. All other telnet traffic should be denied, but all other IP traffic permitted. That's interesting. I think being that we created this right here, there's an implicit deny there. So I don't think there's another rule that we got to do for that deny. But they said all other IP traffic permitted. So we could do another permit for sure. Permit. He said all other IP traffic. So IP, any should be permitted. But isn't this rule right here going to conflict with the other one? Even though we're permitting telnet with this is going to allow anything else or not? Y'all let me know. But I think that's going to allow everybody and everything to come in. Who knows? Y'all let me know. But he said block all telnet. SSH only. Yeah, seriously, right? But and right after that, he says ensure that you enable telnet on a router for the VTY lines. I'm doing this on router B, so I'm good to go so far. Do these rules conflict with each other? Y'all let me know. Show IP, we'll test it in a second. Show IP access list. Right? We got this rule right here that's going to permit any traffic, any telnet traffic to that host right there. So it should theoretically deny anything else and then permit IP any, which sounds like it's going to permit everything else after that. So I don't know. They sound conflicting to me. Let's see. I don't know. We'll test it in a second. But then on task 3, it also says here, ensure that you enable telnet on the router for the VTY lines. So did he say how long this would take? Because we're 45 minutes. Deny all other telnet, then allow all IP. Okay. All right, I'll try that. So I need a rule before this right here then. So I need to make it like 15 or something. Is that what you're telling me, Pete? I'm going to need some help from the Fat Finger Squad. It looks like I'm struggling over here, right? So IP access list. Let's go back to that list right there. Extended allow underscore telnet. And I'm going to create a number 15 rule and say deny. What do we need to deny? Telnet traffic. All other telnet traffic. If I'm going to deny all other telnet traffic, I'm going to say deny TCP any. This is the tricky part right here. This is the tricky one. That is why they call it the challenge labs, man. If I create this rule, isn't that gonna like block this traffic, right? Block this traffic that we just allowed? That's weird. He said, I think the file is read in order, so the first hit works. Yes, it does. So the first hit works, but if I create another rule that says to block everything else, I don't know. I'm gonna add it anyway. Deny TCP any and then EQ Telnet, right? Now let me take a look at that access list. Do show IP access list. So is this right here going to let me know that I'm going to permit this right here, right? That traffic right there to come in. This right here. And then deny TCP any. So deny everything else and then permit any other traffic to it. Right? To any network. Yeah, he says, yes, all other telnet traffic should be denied, but all other IP traffic permitted. To this network? He didn't even specify. I don't know. IP, like, access control lists are pretty tricky, man. Yes, EQ. Can you block by port number? Yes, you can. Just like what Kelvin said. ACLs act on the first matched statement. Okay, but then if I have a conflicting rule, isn't, like, right after that, is it gonna, like, deny it after that? That's my question, Aaron. So I'm gonna go with this for now and go ahead and apply it on the VTY lines while you guys discuss that, or at least answer my question there. So I'm gonna go to the VTY lines 0 through 15. When we say IP access class, right? Or is it just access class? Access. Come on, man. Access class. The name of it was allow underscore telnet. We're going to do it inbound, right? Because it's going into the router, right? Ingress traffic. So going this way. That's why we got to put the in keyword there. We verify our work with the show IP interface serial 000. And we'll see that we applied it inbound. No, it's not. Oh, I put it on the VTY lines. My bad. How do you check ACLs on the VTY lines? Other than the show run. Because I could have done this right here. Line VTY like this. Oops. Show run. Section line. Let's do that. Section line. He said, remember, any of your policy objects in iOS, ACLs, prefix lists, route maps, stop processing when the first term is hit by default. Okay, that's what I need to remember. That's a fundamental rule. Thank you for that, Kelvin. First takes precedence. The processing stops immediately upon first match for policy objects to prevent logical contradictions. Oh, thank you for that rule right there, Kevin. Because I used to think about, like, doesn't this rule, like, contradict what we just said prior to this? I'm glad you said that, and I wasn't really sure. So that's something that's always been in my head with access control lists. When you can have set clauses that compound on each other, i.e. single route map that does an AS path prepend and a local preference set. Well, now you're talking about BGP stuff though, man. But let me see, the exception is a continue clause in a route map, but that's because route maps are more sophisticated policy. Okay, now you're saying, I see what you're saying. But for regular ACLs or just like standard and extended ACLs just like this, then if we have a hit on that first rule, then it just keeps going though, doesn't it? But everything else that contradicts, then we just kind of forget about it. But there is an implicit deny. I see what you're saying though. But anyways, we applied the access control list with this right here on the VTY lines, right? But I was trying to see if there's another show command other than show run to check that. Has anybody figured that one out? So I guess what we can do is what he said here. Test your ACL on router B by telnetting to router B from router A. Telnetting to 170, so telnetting to this should work, but telnetting to the other loopback or serial IP addresses should fail. So I should be able to telnet to this, but I should not be able to telnet into this, right? Or this. So I should not be able to telnet into those two, if this works. So, what he said. Yeah, okay, good. Before we even do that, let's put a password just so we get at least that, because I don't think you'll be able to telnet and stuff like that. And I'm sorry, Professor Blackops, we're all just telnet. I know you're cringing and you're rolling over there in your grave over there using telnet and stuff like that with his compliance checks. But for simplicity reasons, we're using telnet. We need to set a password. So line VTY 0 through 15. We're gonna do the password of the secure password of Cisco, lowercase, just like that. And we're gonna go to router A and test that telnet. Has anybody gone past me yet, or anybody able to create some rules that worked? Because obviously I'm over here struggling. Y'all know I don't know everything, but y'all know I'm showing my faults to the world here. Telnet to 172.16.1.1. Get on our knees, pray to the network gods, and we got refused. All right, so we know that something is being blocked here. Let's go to, we at least hit it, but it got our connection refused. We go to router 3, take a look, show IP access list, and see what hit. We got a match with this right here, deny. So that deny rule right there denied my telnet traffic. But like y'all said, this should have matched it. But apparently it didn't, right? Interesting. I know if I get rid of that rule, I should be able to telnet. But then I'll probably be able to telnet into that. Anybody know why that failed? Mr. Browning, so in simple terms, oh, he said, so in simple terms, are you telnetting to 172.16.1.1, then come in? If you are telnetting elsewhere, then you're blocked. All other IP traffic come in. Mr. Browning's doctorate paper, The Art of Serial Interfaces in Telnet. Seriously, man. This dude got us mastering Telnet and goddamn serial interfaces like it's the wave of the future. It's all good. Learning environment. Got to keep pushing to mama's own. Man, seriously, man. This is what it's all about, man. Breaking and fixing stuff just as long as in a lab environment and not in a in a production environment. So this obviously failed right here. And it's obviously because of this rule right here, because we got a match. So I know if I get rid of that rule, let's go ahead and get rid of that rule, right? I don't think we're gonna do another lab after this, man. My head is spinning over here, right? Access list, extended, allow underscore telnet. We're gonna say no 15. That's gonna get rid of that rule. Do show IP access list. Has anybody finished it yet, or anybody moved on to task number 4? We only got 4 tasks, but I'm on task 3. So I guess I'm 75% complete here. So I got rid of that rule. Let me see. I would think the implicit deny is gonna block me from going into this. That's what I would think, right? Remember, after every access control list, there's an implicit deny. So let's try that. Let's go back to router 1 and try to telnet into that, and hopefully it doesn't get blocked like it did right here, right? Telnet into that. Pray to the network gods. It's asking us for a password. That allowed us in. We don't have an enabled password, so I can't get in. So so we were able to telnet. Can I telnet into this now? Right? Can I telnet from here to there? I would say the implicit deny should block me from doing that. Let's see what hits we got though. Show access list. We got a match there. So it looked like we didn't even get a hit with this. We didn't even get a hit with that. That's interesting. Huh. Interesting. Can we telnet into that? Theoretically, we should be blocking. We should be blocking that. So, because it says here, telnetting to 172.16.1.1 should work, but telnetting to the other loopback or serial interfaces should fail. So let's see. Let's get out of here. Go back to that router. So we're gonna go back to this guy and see if we can telnet to that and that. Oh, we already telnet into that. Let's see if that one fails. So telnet into 172.20.1.1. That worked. So that ACL is not working. So we need to go back to this ACL. What do I need to do here? We need something to block that. What did you guys do? Because I'm allowing everything. Obviously, I got another match here. So I'm permitting that. I need another rule. I don't think this rule is working because I don't have a match. Permit TCP any host to 172.16.1.1 equals telnet. I'm not getting a match with that. What if I get rid of this rule? Let me do a no 20 and see what happens. No 20. I'm gonna get rid of that rule. See if I can telnet into it still. Okay, bad passwords. Yeah, let me out. Let me the fuck out, man. Shit. All right. Telnet into 172.16.1.1. It got blocked. So Let's take a look at our rules. He is not allowing, this is not working. This rule right here is not working. Any host, let me see, any to the host 172.16.1.1. So there's something wrong with this rule right here. Oh, all right. Let's see. Did you guys' rules work so far? Because mine ain't working, obviously. Let's get rid of that rule. I don't like that rule either. No 10. Let's get rid of that. All right, so let's create another one. Permit. We know it's going to be TCP traffic, right? The source. Let's see. Do we want to, let's see what the rule said. Permit telnet traffic to the host 172.16.1.1 from any host or network. Permit. That was what that rule said, man. Permit TCP any. Right there. That's my host. Why the hell didn't it work? TCP. Let's see. We want to do a single source host. Let's do that again. I'm gonna do that again. I refuse to say that didn't work, man. Any destination addresses 172.16.1.1. I'm gonna put the exact destination wildcard bits of quad 0. Is that what I did last time? It don't look like it. It don't look like it, but I did put the host keyword, so that should have done it. That's gonna match that exact IP address, and I'm gonna put an EQ for the port number, telnet. Now let's do a show IP access list. That's gonna permit. That's the same exact rule. See, and that's obviously not working, because if I telnet to it now, boom, blocked. What's wrong with my rule, y'all? Is it something wrong with my rule, or is it something wrong with my routes? I don't think it's anything wrong with my route. Let's see, because we can definitely, let's see. Can we ping it 172.16.1.1? Oops, 16.1. Oops. .1.1. Yeah, we can ping it. We can't create a rule that's gonna block that telnet traffic. Anybody got any suggestions or anything? Y'all see I'm fumbling through this, man. What am I doing wrong here? Let's see. Did anybody else get it correct? And if you're not, maybe I should just resort to the solution guide, man. This is the book we're using, 101 Labs Cisco CCNA version 4. You get a copy of this from 101labs.net. There's a link in the description box below if y'all want to follow along too. Get the book. He did. Let's see what he did. He created an IP, ICMP. No, that's not what he did. Let's see. He did 16 IP routes. Okay, so he did a static route, 0.0 network, just like Pete did. So I see what he did with his static route. But then the access control list, all he did was permitted that whole network. What? Stop. Ping. Let me see. Oh, okay. That's what he did. All right. So this is what he did right here. Let's see. I was looking at the wrong one. Permit. He did access list and then permit TCP any host. He did exactly what I did, so I don't understand it. Okay, but then he created two more rules. One was to deny TCP any. Oh, I forgot another deny rule that's gonna deny TCP. That's exactly what I did. This is what I did right here. Look. Oh, let's see. Where's my deny? I had a deny in here. Where was my deny? This is right here. Deny TCP any equals telnet. That's exactly what I did. And then he did a permit IP any, and that's exactly what I did. What is wrong here? Interesting. This is exactly what he got in his book, y'all. Permit, except he created a numbered access control list. He said permit TCP any host, and then 172.16.1.1 equals telnet. Exactly what I did. Then the second rule was to deny TCP any, which is what I did, equals telnet. Exactly what I did. And then the last rule was permit IP any, which is exactly what I did. I'm at a loss for words, y'all. Let's see what else he got in his configs that worked, or that might have done something differently. Because right there, let's see. He said, yeah, you did it the same. Exactly. I don't understand. Put the ACL on the loopback interface. As opposed to, let me see what he did. Nah, I see what you're saying, Aaron, but he put the if you read task 3, he says, ensure that you enable Telnet on the router. No, I'm sorry. What was that rule at? What was that rule at? Enable Telnet on the router. No, he didn't say anything about that. But when we apply the access control list, we need to apply it on the VTY lines as opposed to the loopback. But I see what you're saying. I see what you're saying. It would make sense to do it on a loopback, but no, he did it. Let me see. No, he didn't even apply it on the oh, I think I see what he did. He didn't do it on the VTY lines. I think I see what he did. And I'm glad you pointed me in that direction, Aaron. He didn't put it on the VTY lines. So when he created the access control list, he put it on the actual serial interface. So let's try this. I'm gonna put this all what I did, because since all this was correct, let's and this is good for me to learn here. So let's do this. I'm gonna fix all of this. We're gonna put all this back in, right? We're gonna put all this back in because all this shit was correct. I didn't apply it on the. He applied it on the physical interface. He applied it on the physical interface as opposed to the VTY lines, and I'll show y'all what I meant by that. What I mean by that. So we gonna get rid of what rules we got so far. What rules we got? Let's see what we got there. That was all correct. Okay, so we got this right here. We got that right there. So let's just add these 2 rules right here. Right, y'all see what I'm doing so far, right? Come on, man. Come on, Vlad. Come on, Vlad. Put those 2 in there. Right? Boom, boom. Right? 2020. And then show IP access list. Right? Okay. So this is exactly what he got, and this is exactly what I had too when I checked the work. And this is what I love about this book. There's a solution guide. He said, here, look, this is how I did it. Well, shit, this is how I did it too, and it didn't work. Why not? So what I ended up doing though was show IP. No, it's not. I don't even know where else to check it, but I know in the, let's do this, section line. When I created that access control list, I applied it to the VTY lines as opposed to the physical interface. And that's what he ended up doing, put it on this physical interface. So let's try that. Let's try that. So I'm going to go to the VTY lines, line VTY 0 through 15. And I'm going to get rid of this access list, access control list, allow Telnet. So allow underscore Telnet. Jesus. And we're going to remove that, right? Now, I'm going to go to the serial interface, 000. We're going to say IP access group, right? Because group is for the physical interfaces and class is for the VTY lines. I don't know why they did it differently. Who knows? But whatever. The name of the access control list was allow underscore Telnet inbound. So now we're applying it to serial interface. Let me see. You said, yeah, you did the same. It's on 000 on router B. Yeah, that's what I did. I think because you were going too fast. Maybe, but I caught myself doing that though. I saw, I was about to put it on the serial interface. I was like, nah, they said Telnet, so we need to apply it on the VTY lines. Maybe I was going too fast. Who knows? So now that we've done that, we applied it on the serial interface as opposed to the VTY lines, right? So now let's go to router 1. Pray to the network, guys, and hope this works. If not, then we got some more troubleshooting to do. But it's all good though, because we love this shit, right? Ping. Well, we know we can ping, so that worked. Telnet into 172.16.1.1. This guy right here. Telnet, and it works. All right, so now Cisco enter. Oops, lowercase. Cisco enter. Good. So that worked. Now we hope that this is being blocked, right? We hope that that's being blocked, right? So let's see. Exalt. I thought I put no IP domain on here, man. The hell? Let me get out of this, man. All right. Then I thought I got it. I thought I put that in my config, man. I guess not. Control Shift X6. The fuck, how you get out of this shit? I forgot how to get out of this, man. All right. Come on, man. Look at this, man. Control Shift. What is it, man? 6X C? Shit. All right, I guess it got out that time. All right, good. Let's get out of this. All right, so now we're back on router 1, right? And now we're going to try to telnet into 172.20. Telnet 172.20.1.1. I hope it gets blocked. It got blocked. Beautiful. Man, and that's just task 3. We got task 4. We got to create one more ACL, and we're going to call it a night, man. I was going to try to do 2 labs tonight, but it looks like we're going to have to just do 1. So I was right. What I learned here is we needed to apply it on the physical interface as opposed to the VTY lines. I don't know if y'all caught that, but remember, I applied the ACL, I'll show y'all, right here on the VTY lines, right here. Where is it? Where is it? Right there. That's where I applied it, on the VTY lines, on the virtual lines that we are blocking or allowing Telnet, right? But we needed to actually put it on the physical interface right there. And the way we did that is with IP access group and then the name of the ACL, right? So, and we can verify that with show IP serial, show IP interface serial, serial 000. You do that and you'll see the access control list right over here. So we don't have an outgoing one, right? So we don't have any traffic that is, ACL is blocking the traffic that's going that way. We have traffic, an ACL blocking inbound. That's what the inbound is. That's why it's the inbound access control list, right? Y'all with me? Control Shift 6. Yeah, man, Aaron, I did that. I don't know why. I don't know why that didn't work. Well, the Telnet traffic is being carried on the physical interface. I understand that, but when would you apply it on the VTY lines? When we're telnetting into, I don't know. So, yeah, I guess I see what you're saying, Pete. I see what you're saying, but I don't know. But that was my main problem. I put it on the VTY lines as opposed to the physical interface. So, let me get rid of all the scribble, move on to task 4, and we'll call it a night unless y'all want to watch me fumble through another lab. So we basically, task 4, final task, I guess we're just over the hour. Add a named ACL on router A. So we know we got to go to router A and create another ACL. Right? There's going to be another ACL here, blocking or denying traffic. Right? He said, add a named ACL on router A so that only hosts on network 2.0, 160, 172, or 192.68. So only hosts from here or on there can be pinged from hosts on network 172.16.1.0. So this can ping that. Only that guy can ping that. Ping. Let me know if y'all already done this part already. Y'all see I'm behind. Take 2 hours. And good thing these exams, well, the exams are timed, but look at me taking an hour over one damn lab with 4 tasks. Woo! I could understand, man. Like, can you imagine lab exams like CCIE when you don't have you have 8 hours, you do, but they have like way more tasks than this, right? But this is what it's all about, man. Practice, practice, practice. Add a named ACL, so we did that. We're gonna do that, right? And then where I annotated it, can be pinged from that, right? All other ICMP traffic should be denied. So if we try to, all other ICMP traffic should be denied, but all other IP traffic should be permitted. All right, so we know we got to do an access control list on router A, right? So let's go out here, go to global config mode, IP access list. He said add a named one. It's gonna be ping. We'll call it the ping ACL, right? So extended. We know it's gonna be extended because we got source, destination, plus protocol. So we're gonna name it a ping ACL. Y'all can name it whatever y'all want. Let me know what y'all using. Are you using GNS3 or Packet Tracer? What are you guys using to practice this lab? Again, we're on page 470, task 4. Only hosts on 172 or 192.168.2.0 can be pinged from hosts on 172.16.1.0. So this right here, this guy is the only one that can ping that. Let's go ahead and do that. So we said we know we're going to permit source, right? Well, we got to do protocol first. He said only hosts can be pinged. So ping is ICMP. We know that, right? Right now, they want us to define the source. From where? From hosts on network 172.16.1.0. 172.16.1.0 /20. But we got to do the wildcard mask, right? So wildcard mask is going to be 255 minus, what is it going to be? 240? Yeah, 240. So it's going to be 15 is going to be the interesting octet. So 000 or 00 dot 15 dot, my bad, dot 15 dot 255, like that, right? And now the destination, this is the source. Right, y'all with me so far? That's the source. This is the destination. Remember with ACLs, you define the source first plus the destination, but he kind of gave it to us backwards on this, so that's kind of tricky. I guess that's why it's a challenge lab. So the destination is, he said, so that only hosts on that can be pinged from that. So 192.168.2.0 network /27. So the wildcard mask, right? So /27, what's the wildcard mask for that? /27 is gonna be 255 minus, what's that? 224. So dot 31. So it's gonna be 0.0.0.31. That should be the wildcard mask, right? Correct me if I'm wrong, y'all. And then all other ICMP, okay, from that host. And then, all right, so that should be that first rule. I think that's it, right? Because we already defined the protocol with ICMP. He ain't say nothing about Telnet or nothing like that. So that's that first rule. That should be that first rule, right? Let me take a look at it real quick. Show IP accesses. Y'all know I like to verify before finishing my work. Y'all with me so far? Did y'all create your access control list yet? Because this is what I got so far. I got permit, ICMP, 172.16.0.0, network. And then this is the wildcard mask. To the that. Permit. So that's what that rule right there is going to be. Source, destination, ping, right? All other ICMP traffic should be denied. So now he said denied. That already tells us the keyword need to be denied. We got to create another rule here. Deny all other ICMP traffic. So we said ICMP. Deny all of the ICMP traffic. So IP or ICMP any. He said all other, right? Source, destinations, any, right? Then he said, but all other IP traffic should be permitted. That sounds conflicting right there, right? But like what Kelvin said, what he said earlier, that the first hit, the processing stops immediately upon the first match for policy objects to prevent logical contradictions. So these two are contradicting each other, but it stops at that first hit. So shout out to Kelvin Tran for that tip right there. Permit. He said permit all other IP traffic. So permit IP any. Those two rules kind of conflict each other, right? But like you said, that first hit. So now let's take a look. We got so far. Show IP access list, and this is our rule here. And I'll check the solution guide if I'm wrong. But that looks good to me, just like it did last time. But this time I'm gonna apply it on the serial interface as opposed to the VTY lines. So that was my issue. If anybody want to point to me, when do you want to apply the ACL on the VTY lines as opposed to the serial interface? I don't know. Probably Probably because of this right here. Like you said, it's going through the physical interface. What he said. Okay, so anybody got questions so far? Did anybody wrap this up yet? Because I'm on the final task here. Test your ACL on router A by pinging 192.168.2.1 from both loopbacks on router B. So we got to go to router B, and we're going to test this, right? So now we're going to try to ping this to that from that loopback, and also from this loopback. But I believe only hosts from 172.20. So then let me see. Let me look at that rule right here. 172. So only this should be able to. Let's see. Let me see. I gotta read that back. So that only hosts on 192.168 can be pinged from hosts on the 1.0 network. So this should be blocked. 16.1.0. Okay, so this should be blocked. So that other one should work. This needs to be blocked right here. Right? So when we try to ping from there to there, right? When we try to ping from here to there, that should be blocked. But this one right here should work. Right? Like we said earlier. So let's go to router B, and try to ping. Pray to the network gods and hope 192. Don't forget to change your source interface, right? 192.168.2.1 from the source of loopback 0, basically. Loopback 0. This should work. We got a reply. Good to go. So this right here worked. Now this right here should be blocked. So let's change the serial interface to, change the loopback, the source interface to loopback 1, right? Y'all with me so far? Loopback 1. Hope that gets blocked. Pray to the network gods. Get on our knees. Bruh. That worked. So something is wrong here. We need to fix that. I thought I was done here. We need to fix this. This needs to be blocked, right? Because he says here, test your ACL on router A by pinging from 192.168.2.1 from both loopbacks. Because he says all other ICMPs should be denied. All other ICMP traffic should be denied. Okay, so let's take a look. Let's take a look at our hits. Let's do that. Let's see what we got. Show IP access control list. We didn't even get any hits. The fuck? Nothing matched up? Something wrong. We got ICMP, deny ICMP. What's going on here? Oh, you know what? I didn't even apply it to the ACL. Just like I was saying. Y'all see what it just dawned on me right here. Like, why the hell none of this shit work? We got to apply the ACL to the serial interface right there. Y'all see that? I was just talking about that, right? Right there. We got to apply it. So how do we do that? We go to Google Fig mode, interface, serial 000. Everything worked. Basically, we allowed everything to work because we didn't apply the ACL. So IP access group, the name of it was, what was it? Ping ACL, right? So ping underscore ACL. We're going to say inbound, right? Now it's applied. We check that with show IP interface serial 000. And we could see that it's applied right here. Inbound access list is ping ACL. So now let's go back to that router right here. This guy right here. And try to ping from there and ping from there. One of them should work and one should be blocked. Ping from loopback 0, pray to the network gods. That worked. Ping from loopback 1, pray to the network gods. That got blocked. And you can see what the U's right there. That basically mean unreachable. We got 5 exclamation points. That means it worked. The U's means unreachable. That was a tough one there, man. That is why they call it the challenge lab. And I was thinking, static routes, ACL, man, we got this shit, man. I should be able to knock this shit in about an hour. Here I am, 1 hour and 18 minutes into the goddamn stream. And I'm just now getting through it. Let's see what he put in the solution guide. The one thing I learned is that I need to apply these ACLs on the physical interface as opposed to the VTY lines. That's where I got tripped up. I don't know when I need to be able to apply those to the VTY lines instead of the physical interface. That's why I love this book, man. Next time y'all want to follow along, get you a copy of this book, 101 Cisco, 101 Labs Cisco CCNA version 4. You get a copy of this from 101labs.net, or there's a link in the description box below. It is an affiliate link, so I do get commission if whatever. If you get it from it, it'll take you to Amazon, and you can get it from there. If you got Amazon Prime, whatever, you can get the book in like a day or two, and then follow along with us. We typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. If I'm stumbling through these labs and stuff like that, and I can't answer your question, there's a lot of smart people over there in the chat room that can help out and stuff like that. Like I said, I'm just showing y'all my faults to the world and stuff like that, man. Yes, I am CCNA certified, but I'm going back to the fundamentals and just kind of like practicing and stuff like that. I'm passionate about this, man. Anybody any questions or whatever? Professor Black Oz, great stream, man. Appreciate you for tuning in. Jason Cliff said, challenge round never easy. It is never easy, man. That's crazy. This is the first challenge lab, and I was thinking, man, this shit easy, man. Static route, man. I did do a practice run on that first one, but I had a Zoom meeting to attend after work and stuff like that, so I didn't even have time to even go through it. Typically, I'll try to do it like a practice lab or whatever, or like a practice run or whatever. But I didn't even get to do it this time around. When I saw it, I was like, static routes. Oh, this shit should be easy, man. Man, look at this, man. Look here, man. This is why I love this book, man. It really challenges us, man. So I hope you guys followed along. Get you, like I said, get you a copy of this book. There's only I think 15 more challenge labs from this, and then we're gonna move on to the CCNP version of this. And I'm going to share you guys my attack plan for the NRC exam as well as the Encore exam. And we're going to be studying for the CCNP lab together, or CCNP exams together. Let me give you a link to the invite to my Discord server if y'all want to follow along, or if y'all have any other questions. If I cancel a stream, I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. But this weekend, I'm gonna be labbing all weekend, man. My daughter's gonna be out of town and stuff, out of the country actually, and we're gonna be going ham, man, with these labs and stuff like that. I'm gonna make sure that I go over ACLs and access control lists and static routes and stuff like this. This shit really humbled me, man. So for now, comment, like, subscribe to the network.